IC 555 timer. This is the IC 555. It is a 8-pin IC. It is a popular timer giving a clock waveform close to the ideal one. It is widely used as both as monostable and astable multivibrator. It is an 8-pin IC manufactured by Signetics Corporation. Pin number 1 is the ground pin, pin number 2 is the trigger pin, pin number 3 is the output pin, pin number 4 is the reset pin, pin number 5 is the control pin, pin number 6 is the threshold pin, pin number 7 is the discharge pin, and pin number 8 is plus VCC. IC 555 block diagram. So this is the block diagram of IC 555 timer. There are two comparators which receive their reference voltages by a set of 3 identical resistors of 5 kilo ohms. This is 5 kilo ohms, 5 kilo ohms, 5 kilo ohms, connected between the VCC, that is pin number 8, and the ground, pin number 1. Comparator 1 has a reference voltage of 2 VCC by 3 or 2/3 of VCC, and for the comparator 2 the reference voltage is 1/3 of VCC. Pin number 5 is the control voltage pin. If this is not required, then a bypass capacitor 0.01 microfarad should be connected between the pin number 5 and ground to bypass noise and ripple voltage from the power supply. Inverting input of the lower comparator is called as a trigger pin, pin number 2. Output of the upper comparator is high if the threshold voltage at pin number 6 exceeds the reference voltage of 2/3 of VCC, while the output of lower comparator is high if the trigger voltage at pin number 2 is less than the reference voltage 1/3 of VCC. The high output of the upper comparator sets the flip-flop because S will be 1 and R will be 0, so Q will be 1, so it sets the flip-flop, while the high output of the lower comparator resets the flip-flop, that is R will be 1 and S will be 0, so Q will be 0. The Q output of the flip-flop is connected to the discharge transistor whose collector is pin number 7. Flip-flop can be externally reset by pin number 4, which is usually connected to the supply voltage to avoid accidental reset. This is the reset pin. Pin number 1 serves as the ground of the potential divider. Pin number 3 is the output pin. Astable multivibrator. In this circuit, when Q is low, the transistor is off. You can see Q is connected to the base of the transistor, so it will be off. When it is off, the collector voltage will be high and the capacitor will charge through a total resistance of Ra plus Rb. And hence the charging time constant is Ra plus Rb into C. As the capacitor charges, the voltage at pin number 6, it increases. When it crosses the threshold voltage, that is the reference voltage at the pin number 5, control pin, it is 2/3 of VCC. So when it crosses the threshold of 2/3 of VCC at pin number 5, the upper comparator output will be high, which now sets the flip-flop. So Q becomes high. So this high output is then given to the base of the transistor. So the transistor becomes on. When it is on, its collector voltage decreases, and so now the capacitor discharges through the resistor Rb and the transistor to ground, The discharging time constant is RB into C. During discharge, the capacitor voltage decreases at pin number 2, and when it falls slightly below the reference voltage, that is 1/3 of VCC, the lower comparator will give a high output. So this will reset the flip-flop. Q becomes now low and the transistor is off again. So this cycle will continuously, it will go on, okay, and the output will get a square wave, this kind of square wave. This is the capacitor charging and discharging waveforms. This is a schematic diagram of the ASTABLE multivibrator. Monostable multivibrator. Here we have to apply an external input at pin number 2, trigger pin. When the trigger input is slightly less than the reference voltage, 1/3 of VCC, the lower comparator will give a high output, that is R will become 1. So this will reset the flip-flop, that is Q will become 0. So when Q is low, that means the transistor will be off. Its capacitor voltage or the collector of the transistor will be high and the capacitor will start charging towards plus VCC. When the capacitor voltage exceeds 2/3 of VCC at pin number 6, it exceeds the reference voltage of 2/3 of VCC, then the upper comparator will give high output. And so S will be 1, R will be 0, so Q will be 1. So this will set the flip-flop and the transistor becomes on, its collector voltage decreases and that will allow the capacitor to discharge. The RC time constant controls the time required to charge the capacitor, and hence the pulse width of the output pulse is given as 1.1 into RA into C. So these are the output waveforms. These are the capacitor waveforms charging and discharging, and this is the trigger input waveform. So whenever the voltage goes below 1/3 of VCC, there will be a change in the output from low state to high state. It will remain in the high state till the capacitor charges and then it goes into the low state. Again it changes its state into high state when the trigger voltage goes below 1/3 of VCC. This is the schematic diagram for monostable multivibrator. Pin 5 is grounded by a 0.01 microfarad for noise filtering. Pin 4 is tied to plus VCC to avoid accidental reset. Thank you for watching this video.